Hi, I'm Hyung Lee from Hanyang University. I'll present our work, Query Lens. Mechanistic interpretability is about describing what's going on inside a model in human terms. The natural thing is to look at it be the individual neurons, but neurons turned out to be polysemantic because of superposition. Sparse autoencoder fixes this by decomposing activations into a sparse overcomplete dictionary, and interpreting those SAE features is what we focus in this work. Logic Lens started out with nostalgia burst as a hidden state diagnostic. You project on intermediate hidden state through the unembedding to see what the model is thinking at the layer. This is then extended to a single MLP subupdate. Since the activation only rescales the logits, the static vector alone determines the token ranking, so Logic Lens becomes a tool for interpreting learned parameters. The same projection naturally applied to SAE decoder columns, and that's now the default vocab space interpretation of SAE features. But applying Logic Lens to SAE feature comes with two limitations. The first is completeness. Logic Lens only tells us about the output side of a feature, which token it promotes, and leaves the input side, which token activated, unrecovered. The second is faithfulness. On many features, especially in early layers, the token turns out to be diffuse subword fragments where Logic Lens sometimes fails to converge to a coherent meaning. So how do we address this? Let's start with faithfulness. Logic Lens captures only the direct effect, which is the feature's projection onto vocab space through the residual connections. But once a feature is added to the residual stream, downstream modules also read it and reshapes its effect on the output. Query Lens incorporates these indirect effects too, not just the direct one. Now let's move on to completeness. Here we adopt the key value memory view of the SAE. Encoder vectors are key features and captures what activates the feature, while decoder vectors are value features and capture what the feature promotes. So we probe both sides of the dictionary, not just the decoder. So Query Lens has two variants. QL value traces the value feature forward through the full stream transition to the output, and that captures the feature's outgoing influence on the logits. In other words, what it promotes. QL key does the opposite. It traces the key feature backward through the stream to the input and captures the feature's incoming sensitivity to input substitution. In other words, what activates it. Logic Lens can be considered as a case where the stream transition collapsed to the identity. Now for evaluation, we use two metrics. The input score measure how well the predicted tokens recover the inputs that actually activate the feature in real text. The output score measure how well they recover the output the feature promotes when we steer it. Across settings, two patterns hold. First, faithfulness. Each QL variant beats its Logic Lens counterpart on the matching side, so indirect effects really do pay off. And for the completeness, QL key wins in input and QL value wins on output, and neither variant alone is enough. We also score semantic coherence of the token set as the interpretability score. This measures how concentrated a method's top tokens are around a single coherent theme, and we let GPT-5 Nano judge on a 0 to 10 scale. Query Lens beats Logic Lens across settings, and you can see what's happening in the examples. Where Logic Lens returns subword fragments, Query Lens converts to a clear concepts like food, banking, or forestry. So to wrap up, motivated by the two limitations of Logic Lens on SAE feature interpretation, we proposed Query Lens. For completeness, we probe both encoder and decoder sides to recover incoming and outgoing causal roles. And for faithfulness, we incorporate indirect effects through the residual stream's Jacobian product. And finally, we also proposed the subspace channel hypothesis in the paper, but we didn't cover it in the video due to the time constraint. But it shows that downstream modules read feature through layer-specific low-rank subspace. Thank you for your attention. For any questions or further discussion, please feel free to reach out to me by email.